All right, geometric sequences. When you're doing a multiply by, and then multiply by, and then multiply by, obviously you can't use the formula from add and add and add and add. So there's a new formula for that. This little x to the minus, or x minus 1, is the whole thing is the power. It's all written teeny tiny and way up there. The whole thing is the power. It's not a little x up there and then a minus 1 sitting down on the line. The whole thing is the power. Okay, multiplying number. Well, what am I multiplying by? 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Yeah, okay, it's got to be 3. 3 to the x minus 1. Again, I'm using x, even though the book kind of interchangeably uses I and n, because I'm going to want that later. Times my starting number. Oh, my starting number was 2. Times 2. And I'm not even going to do any kind of distributive property or anything here. There's no way to do a distributive property. 3 is sitting on the line. X minus 1 is up there in the power. I'm not going to mess with that. 2 can't squish in there, because if 2 squished in there, then all of a sudden it would be getting put to the power as well, and it's not supposed to be. So I'm not even going to try and simplify that. That's just my formula. All right, and then it says I'm supposed to find a 7. So I'm supposed to find the 7th one. 3 to the 7 minus 1, and then times 2. So 3 to the 6 times 2. Definitely getting a calculator for that. 3 to the 6 is 729, and then times 2 is 1458. All right, the other way. So let's see. Multiplying number, well, times 2 is 6, times 2 is 12. Okay, multiplying number is 2. Starting number is 3. Again, I don't try and combine them. That's just my formula. 2 to the 7 minus 1 times 3. Okay, so 2 to the 6 is 64, and then times 3, 192. Okay, so that takes care of formulas for arithmetic and geometric. And those aren't the only patterns people could do. Okay, they're the ones we're going to concentrate on, because they're the ones for which the formula, well, you could just figure out the formula by following one of those little guidelines. Okay, but then I got these things down here like 1, 4, 9, 16. Maybe you know what that is, or maybe you don't. I mean, it's just luck of the draw whether or not you remember squares. Okay, but those are all definitely squares. 1 squared, 2 squared, 3 squared. If you remembered them, you could do that. If you didn't remember them, well, it's not an adding number, and it's not a multiplying number, and so what am I supposed to do? It's just luck of the draw. I happen to know those are the squares, so I know the formula for that would be x squared. But it's not like there was any procedure to get it. It's just you either know it or you don't. 1, 8, 27, 64. Yeah, 64. Those are the cubes. 2 cubed is 8, 3 cubed is 27. Again, you know that or you don't. So, and then this last one, 1, 2, 6, 24, 120. Definitely doesn't look familiar to most people. It doesn't even really look all that familiar to me, even though actually we did a couple of these problems in the very first video of this chapter. 3 factorial was 6. 5 factorial was 120. So 1 factorial is 1. 2 factorial is 2 times 1. 3 times 2 times 1. This is the factorials, but it's not like I even recognize the factorials unless someone comes right along and points it out. So on these ones, there is no plan. This is why the book actually comes up with the words arithmetic for something fancy that we could do with arithmetic problems, and geometric for something fancy we could do with geometric problems. And then it just kind of throws in some of these in passing, because it doesn't expect you to ever be able to figure out too many of these on your own, and there's no procedure for getting the formulas. So that's pretty much all you can do with that. So the chapter does not focus on stuff where you're supposed to guess.